This week we'll be focusing on exception handling. Exception handling is a little bit of a shift from the topics that we've been talking about, but we will be using the idea of class design, especially when we get to the end and we start talking about designing your own exception. So keep those ideas in mind. But exception handling is a kind of a different topic, so we'll be switching gears a little bit this week. So an exception is an object, just like all other things in Java. We have all of our references are either primitives or objects. Well, exceptions are objects. And it's an object that describes an unusual, an erroneous, or an unexpected situation. So essentially, you can kind of think about programs that you write as having two possible ways that they can execute. One would be kind of the normal execution flow, and that would be if all goes according to plan, the user gives you the kind of input you want, kind of everything goes right. That would be one way that your program can execute. And the other way that it can execute is the exception execution flow. So that is if something goes wrong. And it might be something that you expect could go wrong, like maybe your user gives you bad information, for example. But that would be the other way that your program can execute, and you have to account for both situations. So you have to account for obviously your normal execution flow. That's how you write your programs to do what you think they should do, but also the exception execution flow, and that's where you account for things that might go wrong. When an exception happens, so when one of these things goes wrong, the method that thing happens in, that method creates an object, an exception object, and it hands it over to the runtime system. It basically says, hey, something happened here that I can't handle. I'm creating this object to describe that situation, and I'm giving it to the runtime system. And the runtime system then decides what to do with it. Now that object that's created is the exception object, and it has some information inside of it. So it has the kind of error, so what went wrong. It has an error message describing that, and it also contains information about where the program was when this error happened. So it knows what method it was in, it knows what line of code it was currently, the program was currently running, and it also has the stack trace, the runtime stack trace. So that's a history of how we got to where we are in our program. So which method called the current method, and perhaps a method called that, and etc. So that exception object contains all these different pieces of information. Now, when the exception happens and this object is created, that's called throwing an exception. Okay, so when this exception object is created and passed over to the runtime system, that's what we call it. We say that an exception was thrown. When that happens, when the exception is thrown, the runtime system now has to figure out what to do. It has to handle that exception in some way. So what happens is it starts with the method where the exception was thrown, and it sees if it can handle that exception there. If the method that threw the exception can handle the exception, then that's what happens. That method handles it, and you move on. If that method where the exception was thrown cannot handle that method, if it doesn't know, I'm sorry, that exception, if it doesn't know what to do with it, then the runtime system goes up the call stack. So it goes to whatever method invoked that method, and it looks there and it says, okay, can that method handle it? If it can, it handles it there. If it can't, it just keeps looking. So it goes to the method that called that method, looks for a way to handle it there, and it basically just keeps going until it reaches main. And if we get all the way to main and we hadn't found a way to handle our exception, then that means we can't handle our exception and the program crashes. If somewhere along that chain we do find a place that can handle the exception, that method would be referred to as the exception handler. It means that that method knows what to do with that particular kind of error. It gets handled there, and then our program moves on, and it moves on from that method. So it moves on from that handler method to whatever comes next. So when that happens, when we find our handler, that's called catching the exception. So when the error situation occurs, we throw an exception, and then as the runtime engine looks for where to handle that exception, when it finds the place that does, we say that that place catches the exception. Okay. And again, if we get all the way to the end and nothing has caught the exception, then the program crashes. And this is, of course, what we want to avoid at all costs, right? We don't want our programs to crash. We want them to be able to run under lots of different situations. We want them to be robust, meaning that they can handle all sorts of erroneous situations. We really want to avoid having our program just crash. So Java has a predefined set of exceptions that help us in describing lots of different erroneous situations that can come up. Okay, and there's a whole inheritance tree of classes that help us with this, and we'll take a look at those. Now, with these exceptions, there's basically three different ways that you can handle an exception or an erroneous situation. The first is just to ignore it. First is to say, hey, I know something could go wrong at this point in my code, but I'm pretty much just going to ignore it. And if it goes wrong, my program is going to crash. This is generally not a good idea, right? So this is a valid way to deal with exceptions from a syntax perspective, right? The compiler will allow you to do this. You can write code that ignores exceptions. If this is your first time using exception handling, then all the code you've written up until now has taken this approach, right? It's just ignored exceptions. But in general, we don't want to do that. So the second thing we can do is we can handle the exception where it happens. So we can say, okay, I know this method is going to potentially generate an erroneous situation. I'm going to catch or handle it right here in this method. So that's kind of our second option. And our third option is to say, well, an exception might happen here. So this method might do something that is kind of an error. An error might happen here, but I don't want to handle it here. I want to handle it somewhere else in my program. And so if that's the case, what we need to do is take that exception and catch it somewhere else. And that's also called propagating the exception. Okay? We'll look at all three of these approaches in a moment. So how you choose to handle exceptions is a very important design decision. Again, you usually don't want to make this choice of ignoring the exception, but choosing whether to handle it where it happens or handle it somewhere else, that's something you need to think about in terms of the overall design of your program. And this is one of those subjective things where two people writing the same solution to a problem might write it differently, and neither one is right or wrong. It's just different. So again, if you ignore an exception, your program will crash. And when it crashes, it will produce a message that describes what happened. So you do get some information. And this is usually what will happen when you're writing your programs. If you kind of don't anticipate an error situation and then you run the program and it happens, the program will crash because you've ignored that exception that was thrown. But when that happens, you do get some information, and that allows you to then decide, well, really, I shouldn't ignore this exception. I should do something about it. That information you get is the call stack trace. So the call stack trace allows you to find out where the error happened and also the kind of method call trail that led you up to that point. So let's take a look at how this works. And we're going to look at kind of a silly example, but if you've never thought about exception handling before, this is a good little introduction. So we're going to take a look at a program that reads in two numbers from the user and then divides them. So I've written the program already because it's pretty small. So it just creates a scanner object, tells the user to enter in one number, store it as N1, enter in a second non-zero number, store it as N2, then we divide the two numbers and we print out the quotient. Okay, so pretty simple little program. So I'm going to run this program. And this first time I run it, it's going to be normal execution flow. So the program is going to execute how it should execute if everything goes according to plan, mainly meaning if my user cooperates with me and does what I want them to do. So enter number 1, I'm going to enter 10, enter a non-zero number 2, or enter 5, and the quotient is 2. So there we go. Program executed, did what I wanted to do, ended, no problem. So let me run it again, and now I'm going to have that erroneous situation come up where the user does not do what I tell them to do. They do not enter a non-zero number, so I'll again enter 10 for number 1. And now for my non-zero number 2, I'm going to enter 0 because I am a bad user. And when I do that, an exception is thrown. So I'm sure we've all written and run programs where this happens, right? Where a program crashes and we get this red text printed out at the bottom, or might look a little different if you're using a different environment. This is the call stack trace. So this here says an exception was thrown. That means something happened that Java couldn't handle. And it tells us what method it was thrown in. So it was thrown in main. And then it gives us the name of the class of our exception. So this is the type of exception that was thrown. In our case, it's called arithmetic exception. And then it gives us a little message. In our case, it was divide by 0. So this describes what the error situation was. And then here it tells us again exactly where that exception occurred. So it occurred in the class integer divide and the method main, and it occurred on line 15. So that's where it happened. It happened right here. Okay, so this is the call stack trace. So for example, if instead of just a single method, let's say all this code was in a helper method that was called from main, right? So now this program is basically doing the same thing, only main invokes the method helper, and helper actually does everything. if we run this program again, now we get, again, program crashes. We try to divide by 0, which we can't do. Program crashes. But here we say that actually the exception occurred in line 18. So that's, again, where we try to do the division. But that was in the method called helper. And then the call stack trace tells us that helper was invoked in main on line 6. So we can say, okay, the exception happened here, but it happened in this method, and this method was called from here, right? And this would go on and on, right? So if we had another method, so if main called helper 1 and helper 1 called helper 2 and helper 2 is where our exception happened, the call stack trace would tell us all of this. Right? So it would tell us again that the error happened in helper 2, which was called from helper 1, which was called from main. So when we run this program, what happens is our error happens here. Java first looks in this method in helper 2 to try to figure out, well, can I handle this exception here? Is there code that tells me how to do that? And there isn't, because we haven't written any. So it says, okay, I can't, I have to stop. But there's no code here to tell me what to do. So I'm going to go one level up in the call stack trace. What method invoked helper 2? Well, it was helper 1. So I'll go here and I'll look at this method starting, I'm in this line here because this was the one that invoked helper 2. Is there code there that tells me how to handle this exception? There isn't. So again, I have to go one more level up. What method invoked helper 1? It was main right here. So I go here. Again, is there any code here to tell me how to handle this exception? There is not. And now there's nowhere else for me to go, so the program crashes. And when it crashes, it prints out this call stack trace, again, that gives us the trace of where the exception happened and who called that method and who called that method and on and so forth back to the original point of the program running, which was main. And again, the printout also tells us the type of exception, so arithmetic exception, and it gives us the message, in this case, divide by 0. So if we were to write this kind of a program and run it and test it, and when we tested it with a 0, we said, oh, our program can't handle that. Now we want to go back and fix this program using either some perhaps conditionals or using exception handling. Now in a simple program like this, I probably would not use exception handling. I probably would just say something like, hey, if n2 is not equal to 0, then I can do what I want to do. And if it is, then I might give the user some sort of message. Okay, so this would be one way so that even if the user does, if the erroneous situation occurs, I've now handled it. My program doesn't crash, but it kind of dies nicely, right? It ends quietly, telling the user that they've given me bad input. Another option would be I could create a loop and continue to ask the user for a value of n2 until they give me a value that's non-zero. Okay, so those would be some different options. None of those options use exception handling to solve the problem, but I did use exception handling to discover that there was a problem, right, in testing. So that's just a little bit of an example of exception handling, just to kind of introduce you to the idea. But now we're going to look at, we're going to kind of get into the meat of it and talk about throwing and catching exceptions.